Hi, I'm John Paponis of the Biomedical Engineering Department, and I'm going to show you our labs here in the Taubman Complex. This is the Biomaterials Lab, where we study different materials and their interactions with cells and the body as a whole. Come on in. We're interested in both traditional implants made of metals and ceramics, as well as more advanced tissue-engineered constructs. Some of the tools that we have in the lab for more traditional implants include our furnaces, which are used to shape and form different metals and ceramics. This is our FTIR spectrometer, which is used to look at the infrared spectrum of materials in order to characterize their chemical properties. This is our rheometer, which is used to measure the viscosity and other fluid properties of hydrogel materials. In addition to our biomaterials and tissue engineering students, we also have students from our orthopedics lab come in here and look at different fracture patterns in bone, as well as different surgical techniques for fixing those bones in place. One of the important things we teach in that class is also the role that biomedical engineers play in designing and testing surgical equipment and tools. MEMS stands for Micro-Electromechanical Systems, which are miniaturized devices that take advantage of objects on the small scale. In the Biomems lab, we create such devices in order to treat and diagnose disease. In our attached microfabrication cleanroom environment, we have students perform the photolithography or light etching process, which is used to actually create these MEMS devices. We've also had student projects to create gold biosensor-based MEMS devices for the early detection of MRSA, an antibiotic-resistant staph infection. This is the Bioinstrumentation Lab, where we teach students how to create analog circuitry to detect signals from the body and then use those signals to detect and treat disease. Some of the equipment that we use in this lab include waveform generators, multimeters, oscilloscopes, and power supplies in order to power and analyze the output of our circuits. In addition to our Bioinstrumentation Lab course, we also teach our Wearable Technology Design Studio in here, where we teach students hands-on skills such as soldering and sewing in order to design and test wearable devices. The Biomechanics Lab is where we in the Biomedical Engineering Department study human motion. Biomechanics is the study of how the internal and external forces on a body produce everything from a perfect golf swing to a rolled ankle. One of the main tools that we have in the Biomechanics Lab is this Vicon motion capture system, which consists of 10 wall-mounted infrared cameras. These cameras beam out infrared light, which then bounces off of markers, which are placed all over our subject's body. That light then bounces back into the cameras to be reconstructed in our software, where we can then analyze the motion. We can also sync the data from the Vicon system with EMG sensors, which can sense the electrical activity of muscles during motion, as well as force plates, which are embedded in the floor. All of these tools can then be used by biomedical engineers to study things like athletic performance, occupational safety, and the progression and treatment of disease. I hope you enjoyed learning more about our student labs. We look forward to talking with you soon about how to build a happier, brighter future in the Biomedical Engineering Department.